the right. Again, we can say my k is negative because we can write y equal to 1 over x plus 2 as minus 1 over x plus 2. So my k is equal to minus 1, which is less than 0. And our formula says that we have k over x minus b. So we can write that as minus 1 over x minus 2 to get the x plus 2. So my p is minus 2. So most definitely in my domain I cannot have a x value of minus 2. Again, because of the numerator that is unequal to 0, I cannot have a value of y equal to 0. So again, y equal to 0, or the x-axis is my horizontal asymptote and my vertical asymptote is x equal to minus 2. The lines of symmetry are, in place of x I write x plus 2, and in place of minus x I write minus bracket x plus 2, and that will give me minus x minus 2. And we will look at the graph just now. In this case, the blue graph is a green graph shifted 2 units to the left because our p is equal to minus 2 is negative. That's why it's shifting to the left. The coordinates of g and h we can solve. G and h, y equal to minus x plus 2 because our k is negative. K is negative. Therefore, we land in the second and the fourth quadrants. That's where my graph will be. So that's why I take the negative slope. This is to calculate the coordinates of the vertices. So if I solve that, I get minus x minus 2 is equal to minus 1 over x plus 2, and I know that x plus 2 is not equal to 0, so I can multiply it by that, and perhaps I should have just done that. Let us just leave it like that. So then I get minus x plus 2 squared is equal to minus 1, so therefore I get x plus 2 squared equal to 1. So x plus 2 is equal to plus 1, or x plus 2 is equal to minus 1, because our answer is plus or minus if I take the square root there. In the first case I get x equal to minus 1, and in the other case I get x equal to minus 3. For x equal to minus 3, if I substitute it into that value there, then I get minus 3 plus 2, which gives me minus 1 inside the bracket, minus 1 inside the bracket times a minus, which is that. And for x equal to minus 1, if I plug it in there, I'll get minus 1 plus 2, which is equal to minus 1, which is equal to minus 1. So that is my h value. So let us look at the graph. Please ignore that point there, it's accidentally on the graph. First of all, this is our y equal to x of our one line of symmetry of the original, the reflected mother graph, and y equal to minus x. This is my graph y equal to minus 1 over x, and also this one y equal to 1 over x. This is our mother graph, the reflected mother graph. Now we can see that from A to H we've moved 2 units to the left, and from B to G we've moved 2 units to the left. My line y equal to x moved 2 units to the left, and my line y equal to minus x, we can show it here, moved 1, 2 units to the left. And our vertices, we've already calculated it here. This is where they intersect with this line y. This is the line y equal to minus x minus 2. And this one is the line y equal to x plus 2. And that is it. So our conclusion is, if k is negative and p is negative, then our hyperbola shifts horizontally p units to the left. P is negative, then we go left. The vertical asymptote, as well as the two axes of symmetry, shifts with the graph. All three of them shift with the graph. Or if you memorize the mother graph and the reflected one, then this is really not difficult to do.